This short video is about adding phantom power to probably a vintage desk that doesn't have it already built in. Back in the early days of condenser microphones, you had to have a power supply on the studio floor, which got kicked and damaged. Then came along this wonderful thing called phantom power, and the power is carried up the mic line to the microphone. Now we have to be a little bit careful here, and I'm going to take you through this drawing in some detail. Firstly, up here we have 48 volts coming in. That 48 volts of course should be highly smoothed and stabilized, and preferably come from a discrete, not switching power supply. We have a switch on each microphone channel, because we really don't want to apply phantom power to, say, a moving coil microphone or any microphone that doesn't need it, because some of them do object, although in theory everything should be balanced so the microphone will not be damaged. We have here some smoothing components, and then we come in here to two really important items, these 6.8K resistors. These should be low noise and at the very least plus or minus 1%. Use plus or minus 0.1% if you can get them, because it's vital that the voltage here and the voltage here are exactly the same. Here we've got two isolating capacitors, because again, although in theory there is no voltage potential across here, the voltage potential is from here down to ground, of course, it is likely that some DC might get into the mic transformer, and DC in the primary of a microphone transformer will promptly cause the core to saturate. These are 22 microfarad capacitors, 100 volts working, but please notice here NP. NP stands for non-polarized. Electrolytic capacitors generally need a voltage across them in order to maintain the insulation between the two sides of the capacitor. With non-polarized capacitor, this is not necessary. Now, as I just said a few moments ago, there should be no potential difference between here and here, so there's no voltage to maintain the insulation in a conventional electrolytic capacitor. Here we've got two 10 ohm resistors, plus or minus 1%. They're there because here you notice we've got two pairs of Zener diodes back to back. Now that is just in case any spikes happen to arrive down here, and therefore the Zener diodes will shunt those spikes down to ground rather than going to the mixer. And finally, two grounds here, signal ground and chassis ground. Now, I must refer you to the other videos on the page. Signal ground isolated like this is where both the inputs and all the outputs from your desk are transformer balanced. If they're not transformer balanced, then signal ground and chassis ground are probably going to be the same. Although if you look at my video on ground central, you'll see how we connect various grounds to what is termed ground central.